This video is the third video about regularization for LeetCode 382, linked list random node. In this question, you are given the head of a linked list, and you need to uniformly return a node value wherever getRandom is called. The constraints are the following. There are at most 10 to the 4th nodes and 10 to the 4th getRandom calls, and all the absolute node values are within 10 to the 4th. There are also two interesting follow-up questions. What if the linked list is large and the length is unknown to us, and whether we could solve this problem efficiently without using extra space? The most straightforward solution in my mind is to keep all the values in an additional array. I'll call this solution array solution. We'll convert the whole linked list of nodes into an array. Previously, we need to go through each node in the linked list, so it will take all time. But now the random access will be just O1. The downside of this solution is also very obvious. All the values have to be duplicated, and thus extra space is required. Because of the need of preprocessing the whole linked list, the array solution won't meet requirement for the first follow-up question, in which it asks the linked list is super large and the length is unknown to us upfront. So this solution will not work. An alternative solution is called the Reservoir Sampling. It will work on the streaming of values, so you don't need to know the number of nodes upfront. It was used to be a trick that only a few people knew, but now it becomes a very popular interview question and everyone needs to learn it. Despite of its fancy term, the idea behind reservoir sampling is very simple. You just need to make sure the probability of keeping each of the streaming value is the same as 1 over n, where n is the number of values you have seen so far. Let me write down the pseudocode of it. Let's say we have a sampled value equals to none. Now I need to go through the index and the value of that streaming of values. Even though here I regard values as a container, it doesn't really matter as long as I know the index and the value itself. With these two information, the same thing I would do is random.randInt from 0 to index. It is because index is 0 indexed, and then the randInt requires close intervals. If this value happens to be 0, then I will update my sampled value equals to value. And this is basically the pseudocode. Notice that this reservoir sampling can be generalized to keep not only one sample, but up to k samples. And if k equals to n, as n grows over time, this approach practically can generate a random shuffle array of samples. In terms of how to do this, I will leave it as a bonus question for you. If you are interested in knowing the answer, please leave a comment below. Now let's think about the second follow-up question, in which it asks us to come up with an efficient solution without using extra space. Unfortunately, I think this follow-up question is self-invalidating. In order to solve something more efficiently, one has to make some sacrifices, usually through using more spaces. If no extra space is allowed, I really don't think a more efficient solution exists. Alright, now let's move on to the code implementation. I'm going to implement two different solutions. The first one is the array solution, which has a time complexity of O n plus q. N is the number of elements, and q is the number of queries, as well as space complexity of O n. For the initialization, I will need to have an array to keep all the values. I will need to do while add self.array.append add.value. I need to move add forward. Once I have the array, I can now do the sampling. Also return self.array random.lengthInt 0 and length of self.array. This is very straightforward, but we still need to test it out to see if it works. All right, we pass the test cases and do a submission. Okay, you can see it's very efficient because this array solution allowed us to do random access in no one time. So it's very, very efficient. However, we also want to answer the first follow-up question, right? In which I cannot see all the nodes at the beginning. Instead, I need to process the value in a streaming way. Code is Reservoir Sampling. The time complexity is, however, a lot worse because each time I need to go through the whole list. And if you have Q queries, the time complexity becomes Q times N, whereas the space complexity is just O1. That's a trade-off. Let's think about the initialization. In terms of initialization, I only need to keep the head. I will say self.root, which means the root of the linked list equals to head. And now, within the getRandom function, I need to keep the index of the value, which starts from 0. I also want to keep the return value equal to none. Head will be initialized as self.root. After this, we're going to take the streaming values in. While head is now none, we'll roll a dice here. If random.randint 0 to index, we don't need to +1 here because the range for random index is inclusive. If the output for this guy is 0, it means that we should keep the value. The return equals to head.value. We're going to increment the index by 1 and move the head forward. Eventually, we'll just return the sample value. As usual, let's test if it works. Okay, it still passed the test case. Now let's do submission. All right. You see, now the speed is a lot worse because the time complexity is Q times N. It's a lot worse than the array solution. However, it allows us to do the streaming sampling, which could be very helpful in some cases. All right, that's the end of this video, and thank you for watching.